Good morning, everyone. I've got a Homag input-output board, and the complaint is that input number 5 is not working. The LED is not turning on. Let's work out the circuit and we'll test it. Alright, we're going to draw the circuit out of that input so we can figure out how to test it. Now the LED has a light pipe, so the LED is down underneath this plastic right here. I can see it, and it looks like the input goes through the LED to this 1 kilo ohm resistor. So let's draw our orange connector. Here's our LED. Here's our 1 kilo ohm resistor. It's half watt. Now, where does that go? It's right there. Okay. There's a forward bias diode. It looks like there's a resistor attached to it. A little dot there and we'll come back to that resistor. Then it goes to a Zener diode. Has a blue band on it. Now let's see where the output of the blue banded diode goes to. Alright, it goes to pin 3 of that Opto-Coupler. Pin 3 is the anode side of the LED inside that Opto-Coupler. Pin 4 on that Opto-Coupler is the cathode side of the LED. That's part number TLP 621-4. Let's see where pin 4 goes to. It has to go back to ground. Yes, it does. Pin 4 goes to ground. So we'll put a little ground symbol right here. This is the orange connector. We're going to label that one pin 5, and this LED is number 5 LED. Now let's check out this resistor right here in this SIP package. Does that go to ground also? In ohms mode. I'm going to go to pin, let's see, where is that? Pin 3 goes to this one. Alright, it's 3.3 K pulled to ground. And that was on pin 7. Pin 1 is the common of all that resistor. And that's 3.3 K. Okay, we have the one input mapped out. Now all the other inputs will be identical to this, so there's no need to map out all of those inputs. Once you map out one input, the other ones are the same. Now we have to map out the power coming in. What does that look like? That's this section over here. It looks like this green connector over here, the power coming into there, is for the outputs. These are driver transistors. And they drive the outputs, but we're only worried about that one input. So let's map out our side over here. We have the green connector. There's one pin, there's the other pin. On the front, that's labeled EO1. Green. There we go. Now it looks like we have an MOV, some capacitance and inductance. The capacitance is tied to frame ground. It's tied to this metal plate. Okay, we have a capacitor on each side of the inductor. The MOV is across the two pins, and then there's a capacitor at the final output. So let's draw all that out. We have an MOV. We have a capacitor to frame ground. We have an inductor. Another capacitor to frame ground. And then a capacitor at the output. Now it looks like that pin doesn't go anywhere. It stops right here. Let's do the ground side. We have an inductor. This connects right here, and this is our ground for that circuit right there. We have two capacitors on each side of the inductor going to frame ground. There it is. There's the circuit. Now you're probably wondering why the positive side doesn't go anywhere. Well, it actually is used as a filter for your inputs, because we're going to apply 24 volts DC reference to this ground right here into the Opto-Coupler through this LED 1 kilo ohm forward bias diode Zener and into the Opto-Coupler back to ground. So this is for noise suppression of that input, that 24 volts DC going to that input, but I'm not going to hook it up. All I'm going to hook up is the ground and take the 24 volts DC from the external power supply and ground into those inputs. Well, that was an easy circuit to map out. Hardly had to use the meter at all because I could see the traces. Let's set that off to the side and we'll test those inputs. Alright, let's adjust our external power supply that we're going to use to drive those inputs. We'll adjust it to 24 volts DC. We'll connect the external power supply, its ground side, to that green connector. And we're going to use the positive side to probe those inputs. I'm going to try to do this without getting in the way. There's zero input is made. Can y'all see that LED? And the LED is on. Here's the one input, LED is on. The two input, LED is on. 3 input, LED is on. 4 input, LED is on. 5 input, oh, look at that. Sure enough, that LED is off. Let's test the other ones. Here's the 6 input, LED is on. 7 input, LED is on. 8 input, LED is on. 9 input, LED on. A input, LED on. B input, LED is on. C input, LED is on. D input, LED is on. E input, LED is on. F input, LED is on. Let me go back to these other ones. I think my hand was in the way. There's 8, 9, A, B, C, D, E, F. 0, 1, 2, 3, 4, 5 is off. 6, 7. Well, we got a little bit of troubleshooting to do. We got to figure out why that number 5 input is not working. Now we're going to check the LEDs in that input circuit. But we'll also check, I'll do that off camera, but I'll also check all of the other devices in that circuit. I want to check the LED because reason being, we have a 1 kilo ohm resistor here in the circuit, and that 1 kilo ohm resistor doesn't look bad. It measures good. So I would expect, you know, if the LED wasn't turning on, there would be something else bad in that circuit. So I'm going to check the LEDs. And I hope I don't get in the way here because this is really tight. I want you to see that you can set your meter to diode mode. Let me turn that light on right there. You can set your meter to diode mode and turn on an LED. Can you see that? I just turned on that LED. That's input 0. And we've got 1.764 diode drop on the meter. Let's go to the next LED. I know this one works. There, we just turned that one on. I got the red lead on the anode of the LED and the black lead on the cathode of the LED. We got 1.821 volt diode drop across that LED. We'll go to the next one. We've turned that one on. We got 1.619 volt diode drop. That was 0, 1, 2. Here's input 3. LED is on. 1.691 volt diode drop. Here's 4. The LED's on. 1.615. And here's the bad one. And that LED is opened up. It's not turning on. Input 6, 1.618, the LED's on. And here's the last one, input 7, that LED's on, 1.623 volt diode drop. So we have to replace that LED. Well, since we're here, let's check the other components in that circuit. It goes to this 1K. We got 995 ohms, that's good. Let's go back to diode mode. We have a diode drop of 0.605 there, that's good. Go to the Zener diode, 0.745 volt diode drop across the Zener diode, that's good. Let's go to the Opto-Coupler's input LED. We got 1.033 volt diode drop, that's good. Now if you were ever unsure, you have all of these other components to compare to. Let's check the 3.3K pull down resistor. And that's good. 3.2 kilo ohms. 3.288 kilo ohms. So everything in that circuit is good except for that input LED. I don't have that on hand, we're going to have to order it. That's a surface mount LED. We'll come back in a couple of days when we get the new parts and we'll test it again. We'll see you then. Here's a close-up of the input circuit. Now here's the orange connector on the front of the card. Here's the LED that's opened up. It's not illuminating when we apply 24 volts DC to this circuit right here. Here's 1 kilo ohm half watt resistor, that's good. Here's the forward bias diode and the 3.3 kilo ohm pull down resistor to ground. Here's the Zener diode. I'm not sure what value that Zener diode is, but it measures good with my diode test mode. And here's the input Opto-Coupler, the anode side on pin 3 of the TLP621-4 made by Toshiba, and the cathode to pin 4 and ground. So when we apply 24 volts DC to this input, that LED should illuminate, and this circuit conduct and turn on that Opto-Coupler. Photons emitted from the LED to the base of the phototransistor, turning that transistor on. But since this is opened up, that circuit's not working. Now let's go down and look at the 24 volts DC and ground power input. Here's a close-up where the 24 volts DC and its ground from an external power supply are applied to that circuit. We have an MOV right here, 2 capacitors, and an inductor, and another capacitor, 2 capacitors here and an inductor going to ground of that Opto-Coupler input circuit. And this is called pi filtering, and they're used for noise suppression. And the MOV is used to shunt any extremely high voltages across that MOV. And that MOV will sacrifice itself and pop a fuse. If there's a fuse over here, there should be.